A C program is a combination of variable definitions and functions. So today we're going to focus mostly on the syntax and technical details about C and C++ functions. Generally speaking, functions encapsulate some kind of computation or action. So of course main is the entry point, the top level entry into the program. So regardless what's on top of main, what's below it, it's always the main function that is going to be invoked by the program loader. C math library functions are square root, sine, cosine, and so forth. For instance, if I wanted to use one of these, I could just say include C math. This is a C math library. In fact, C stands for C. C library included in C++, and math, of course, would bring all of these functions into the scope of our program. And here we could type for example, square root of some value like 123.456, which is a real number. I could add a new line right here for clear formatting, and also prompt right here that this is a square root of 123.456. So we can say equals this, and also add another new line and the end here. So square root here is an example of invoking a function not defined by us, but the function that comes from the header, the system header. So let's do a quick try running this. Build. Oh, there's a misspelling here. I press Control F5 to run this program, and you see that the 123.456 square root is a funny looking fraction like this, 11.11. These are examples of other library functions that you can use in your program. And of course, you would define your own functions to validate and store data. More examples of square root and other functions that come from this library header. This is a C library header that brings in all the entire collection of functions, mathematical functions, trigonometry functions. And so this is the example that I tried over here. Another very popular functions that come with standard library come from this specific header file. If I just include this header file right here, I can show you that, for instance, we can try to show right here the type of a character. So characters could be alphabetic, lowercase, uppercase, digits, and so forth. So if we try this, we can say that, for example, we can verify if character is an alphabetical character or character is a digit. So we can say, is digit, for instance, something that looks like 1. So that should print a digit. And I will repeat this. On another new line, and let's try two sets of these. We can try uppercase A as well, and see what happens if we try these two lines to find out whether 1 is a digit or A is a digit. So I go to build my solution again and press Ctrl F5 to run it, and you can see that the outcome of 1 is 4, which means that if it's a non-zero, then yes, indeed, this is a character that represents a digit. Otherwise, if it's an alphabetical character or punctuation character, you see that it returns a 0. So generally speaking, 0 here indicates false, that no, A is not a digit. Now also notice that when I make calls to isDigit, which is one of the family of these character classification library functions, when I call and provide 1 and A, I enter them in single quotes. So single quotes encapsulate literal characters. So a single character, unlike a double quote, which encapsulates a literal string, a single quote represents character literal. Basically, one character represented literally. Of course, we know already from our previous presentations that these characters have their own encoding, and this is a way to represent individual characters. So again, the outcome of isDigit 1 is non-zero, which means yes, it is a digit, and A is 0, which means that it is not a digit. Of course, if we try to call is alpha, which means to tell us whether this character is an alphabetic character, and again I rebuild the program and run it again. You see that once again, this time is alpha tells us that character A, yes, indeed is an alphabetical character, because the outcome of this function call is a non-zero. Just be aware that there is this rich variety of character classification functions which can analyze individual characters and answer your question regarding the type of character that we're dealing with. Let's talk about functions beyond main function and also function parameters. So here's an example of the function square, which simply takes an integer parameter and multiplies it by itself and instantly returns the result. So for example, if we enter integer value 5, we create this variable. In fact, let's try this entire sample to replace what we currently have. So now we have an example of brand new function named square. You will recognize that this is a function because it has parentheses, and compiler will understand that once you start using parentheses next to the name, this is not a variable, it's a function. And inside parentheses, our main function has nothing, which means our version of main is not taking any parameters, but this function square takes a parameter. It's using its parameter as a normal integer value when it does its computation. Of course, asterisk here is a multiplication, and we multiply this parameter by itself and return it as a result. In main function, we first create a value integer. Of course, it's a local variable that belongs to function main, and then we make a call into this function square, and we provide the actual parameter, which is this specific integer. So notice in this diagram that basically shows the timing of our execution, that we of course start execution in the main function, and then we call function square. Right here, this is an example of a function call with a parameter. So the control of our program is transferred to the square function. So right here, everything freezes until we come back from this function call. And so when we make function call, this part of the program begins to execute. First of all, variable x is initialized with the value that was originally set right here. So x also becomes a 5. Then we use it to do our math, compute the square of this number, and we return the value back. So at this stage, when we say return, the function stops running, we come back to function main, and the result from here is assigned to the new variable named result. And so here, once again, once the square stops running and finishes everything that it does, we come back with the result to our main function. So notice this gap, which basically represents that while this function is running, nothing is happening here. It's just everything is frozen and waiting for this to finish and come back, and then let continue the main function execution.